All right. So we worked on this for a bit, so let me go through the solutions for it. Okay. What I'll do also is I'll email the notes to you guys as well, because that will have the solutions to this example, that is. Okay. Oh, there it is. All right, cool. All right. So here we want to do this. Okay, so again, notice the denominators, they're not factored, right? They're not. What do we do then? Well, we have to factor these denominators, as you can see. So we have x squared minus 9, right? So that's going to be, right? We've factored this before, x minus 3 times x plus 3. It's a difference of perfect squares. We have done that before. Here, for the second one, we have 3 terms, the trinomial that is. The leading coefficient is 1, and the exponent here is 2. From there, we get x minus 5 times x minus 3, as you can see. That's great. And so we have, excuse me, I skipped a step, I'm sorry. So we have 3 terms, the leading coefficient's 1, degree 2. So we want 2 numbers whose product is the constant term and whose sum is the coefficient of x. So we want 2 numbers whose product is 15, the sum is negative 8. Okay, what numbers do that? Well, 15, which is negative 5 times 3. Right? Because that's going to work because negative 5 times, plus 3 is also negative 8. So because of that, we get this. That's why we know this is the factorization. X minus 5 times x minus 3. Okay, so now we have the denominators factored, right? Let's get the LCD. So we have x minus 3, x plus 3. We have x minus 5, as you can see. Now, the biggest exponent, right? Well, for x minus 3, that's in both denominators, as you can see, when they're factored. The only exponent of it is 1. So x minus 3, the greatest exponent is 1. X plus 3 is only here. Its exponent is 1. So we get a 1. X minus 5, its only exponent is 1. So we get a 1. So the LCD is this. X minus 5 to the first, x plus 3 to the first, x minus 3 to the first. That's what we get, as you can see. Awesome. Now we want the denominators to be the LCD. Okay, so I put the factorizations in here, as you can see. Now from the first one, you can see we're missing x minus 5. No big deal. We're going to put it here and here. Here, right? We need to multiply the denominator by it. That's what we're doing. But whatever you do to the bottom, you do to the top. So that's why we have x minus 5 here as well. Not only that, for the second one, as you can see, we're missing x plus 3. Okay, that's cool. Well, let's multiply the denominator by x plus 3, right? That's what we're missing to get the LCD. Whatever we do to the bottom, we do to the top. So that's why we're multiplying top and bottom by it. And now when we subtract, the denominators are now the same. We get this. Here, we have 3x times x minus 5 minus this. So we have 3x squared minus 15x minus 3x squared plus, so again, now we're going to FOIL, right? We're going to multiply. So we have 3x squared minus 15x. For the second product, notice I'm using parentheses, right? Because again, you want to distribute that negative. So we get 3x squared plus 9x minus 5x minus 15, right? So now this negative, we're going to distribute. Okay, that's why I have parentheses. You want to make sure you distribute the negative. So once we combine like terms, now we distribute. We get negative 3x squared minus 4x plus 15 minus a negative is plus. Now, if you combine like terms, what happens next? You get this. Now, is this simplified? Well, the denominator is clearly factored, and the numerator is also, right? But you can see that the numerator and denominators, they don't have any common factors. So hopefully you can easily see that the numerator and denominator, they have no common factors, and thus this is simplified. Okay, and that's it for this, not for today, I mean, but that's it for this section. Are there any questions about this? Okay, so let me start chapter 8. Let me see if I can, let me just share it for you guys, for everyone, I mean, excuse me, I'm sorry. Here we go, excuse me, here we go. Chapter 8, what we're gonna look at is a system of equations. So in this case, you'll actually see, we're gonna solve more than one equation at the same time. You know, so we're going to kick it up a notch from what we saw in chapter 1, I guess, right? You know, chapter 1, mostly 1.1, we saw equations and how to solve them. We're going to now solve more than one equation. We're going to solve a system of equations. So in this chapter, well, first we're going to see what a system of equations is. And what we're going to do is we're only going to focus, though, on linear equations. Remember, that's when the variables, their exponents are 1. So it's not like you're going to have x squared, you're just going to have x in there. We're going to see how to solve a system of such equations 3 different ways. Usually when I teach the class, I've only done the first 2, but we have some more time left, so I want to do elimination. I find most people use elimination if they can anyway, maybe because for them it's the easiest, I don't know, but I figured it'd be good to try to present 3 methods for solving it. Sorry, I don't want to go too fast. Okay. So here, you know, again, math is just like any other science, right? There are going to be some definitions. Okay, and I don't think we're going to get past this slide today, but mostly we're going to look at this kind of system. I mean, we'll get more into that next time. So I think from next time we'll start from this slide. All right, so let me stop.